4-day week next week. Friday. And then we start break. Yeah. How long is break? Usually it's a week.
So you do full week, Friday, Saturday, Sunday.
Yeah. Another Friday, Saturday, and Sunday too. Yeah.
Wow.
Yeah. Crazy times. My God. Next week we're here for 4 days.
Then we have Friday.
All right. Anything else secondary we need to talk about before we get? It went real well, actually. It was nice because it lasted until like 10:30. Probably when you got no, I'd say around 12:15. Took myself a nap on Friday. What? I wasn't playing. I was watching and talking to people. So RPI. All right, here we go. Quick review of these polar grids, because today you're not going to graph an angle for me. You're actually going to graph a physical point somewhere on here. All right, so I just want to make sure we remember where all the angles were. If you're in degrees, it goes by what amount? Goes by 15s, remember. If we're in degrees, these go by 15s. If we're in radians, which most of the time we'll be in, it goes by pi over 12s. Yep, pi over 12s. What's that pi? 2 pi over 6, so on. Okay, goes by pi over 12s. All right, so just something to remember. You always, anytime you're going to graph in radians, guys, try to be out of 12. So you can just simply count how many there are. All right, try to be out of 12 as much as possible. All right, so here's how we're going to graph these. You're going to take a look at part A here. It looks like it's an XY coordinate, just like usual. All right, it's an XY coordinate. But now, instead, that first coordinate's called the R value. All right, that's your R value, which is your directed distance, and I'll talk about more of that in a second. And the second coordinate will be your angle measure. Okay, where on the grid to go. On the XY axis, what was this middle point called here? It's called the origin, right? This middle point here on your polar graph, that's called the pole. Okay, not the north or south pole, just called the pole. Okay, that's where you start. It's like the origin for the X and the Y. All right, so how do I graph these bad boys? 3 pi over 4. Find me where pi over 4 is first. All right, find me where pi over 4 is. What's pi over 4 as far as the 12s go? It's what? 3 pi over 12, right? So if you go, let's see, here we go. 1, 2, 3. It would be right here. This is where pi over 4 would be. Everyone agree? Okay, now the R value, that directed distance, that's how many units away from the pole it is there. So it's 3 units away from here at the pi over 4 level. So if I start from the pole, everyone go 1, 2, 3 units out. And there is 3 comma pi over 4. Okay, no arrows, no nothing. I'm just plotting the point. That is 3 pi over 4 right there. 3 pi over 4. Okay, that's where it's going to be. I don't know about you guys, but it gets kind of tiresome on the eyes a little bit, all right, especially with all these lines flying around. It's hard for me to tell how many I'm going out, but you guys are young cats. I'm sure you could do it. All right, 2 135. Ready? 2 135. Well, I know this is 90, right? Up at top, I have 90 here. Keep going around with me. Add another 15. Little help. Add another 15. 105, 120, and then right here will be 135. So I'm right here. And I go how many units away from the pole now? 2 units away. So 1, 2, this point right there. What? Why don't you calm down? Can I finish teaching here? No, can I just want to label it. Whew. All over me today. Questions? I can't deal with that. I'll talk later about that, about something. All right, yeah. Now what's the difference? What do you notice about your R value? It's negative, right? It's going to be graphed differently. All right, it's going to be graphed a little differently. So first of all, can you find me where 3 pi over 2 is? Where's 3 pi over 2? Three pi over 2 is the same as what, if you don't remember where that is, it's the same as 270. If you wanted it at a 12, it would be 18 pi over 12, so you have to count 18 spots around. But here it is right here. And I don't need this marked at all. You guys, I'm just showing you for teaching purposes. All right, what's the deal with the -3? What do you think? You're going to go opposite now. You're going to go opposite. All right, so instead, ready? Take a look. Instead of going 1, 2, 3, I'm going to go 180 degrees the other direction here and go, let's see if this is where it kills me, a straight line here. So 1, 2, 3, that's where my point would be, on the direct opposite side. Okay, it's kind of, hey, if you graph 2, 6 versus -2, 6, here's 2, 6. What are you doing to -2, 6? You're going on the opposite side. Same thing works for the R value if it's negative. All right, I'm going on the opposite side. And then -1, negative pi over 4. All right, everyone hold up. Can you find negative pi over 4 on your own? Can you find where on the graph negative pi over 4 is? Turn it into 12 if you need to. What is it in terms of 12s? -3 pi over 12, but remember, you're going, okay, but clockwise though, right? Clockwise. So ready? I'm going to go 1, 2, 3. Here's where it would be. And now I'm going to go in the opposite direction, 1 unit off from the pole. I hate doing these up here. Right here. I think that's opposite. Yeah? How's that look? All right, good talk, everybody. Thanks for helping me out. Don't, can you, and I can't. I cannot take you seriously. I can't take you seriously with, let's just throw it all out there. Can't take you seriously with the creeper stash. All right? All right, I feel like you should be over at Eagle right now, giving out candy in a van with no windows. All right? That's what I feel like right now. All right, too harsh? Did I go over the line there, anybody? Oh, sorry, right there. Wanted, right there. With that stash. All right. Whew. How do we feel graphing now? We feel all right. All right. Graph these 2 points on the same one now. Graph these 2 points on the same one. 2 pi over 3. All right, let's take care of that one first. 2 pi over 3. All right, where's pi over 3? That's the same as, let's see, 4 pi over 12. 4 pi over 12. So let's see, 1, 2, 3, 4 right here. And I'm going to go 2 units away from the pole. So 1, 2. And then go -2, 4 pi over 3. Remember, -2, opposite direction. Let me know what you find out. Let's see, out of 12, what's that, 16 out of 12? 16 pi. So that's 12, 13, 14, 15, 16 right here. And what are you guys noticing? Everyone understand it's the same point? Because right here would be my 4 pi over 3, but I need to go opposite 2. It's the same point. All right, real quick, here you go. I need you to write a couple things down here because here I'm going to ask you to rewrite these. I'm going to give you this, and I need all the points that are the same as it if I graphed it. So let's talk right now. Let's say I start with your r theta. If I kept the r the same value, positive, how could you find me another point that's the same? What could I do with theta? Think back to what we did at the beginning of end of last week, at the beginning of this unit. Add or subtract. So I can take theta and add or subtract 360 to it. If you want the same point. Everyone good? And also, quick review, 360, same as what in radians? 2 pi. Okay, remember that. Same as 2 pi. All right, or we just found out you could make that r value negative, but be careful here. What would I want to add or subtract now to that theta value to get to that point? On the opposite side, Abe, add or subtract 180. Which is, quick review, what in radians? That's 90. Easy stud. Pi. Yep, pi. Okay, so these are two different ways I could get the same exact point. All right, I'm going to go real slow here because we only have what? What do we got here, Trent? 2 more problems? Good talk. Okay. You and Matt joining the same league here, huh? Yep. Is this a fifth period thing? You're just in your own league there. What? No, he's in his own league. Yeah, he's in the own league. The crust? Oh, God. It's mean, all right. Yeah. All right, here we go, everyone. Here we go. Select a point that does not change. All right, so 140. I got 4 choices here, and there's more than one answer here. Out of these 4 choices, if I plotted it, would be the same point as 140. That's what I want to know right now. All right, out of those 4, which ones would be the same exact point as 140 degrees? I'm not using the graph. I'm not using it. We just found out how we could figure out the same points. So 140 would be the same as, okay, let's say I kept 7, positive 7. What are you going to do to the 140 to find multiple points that are the same? I'm going to take 140 and add, subtract 360 to it. Go ahead. So if you want to keep the 7 positive, you add and subtract 360 to your angle. So tell me the other 2 points that would be the exact same as 140. 7, 500, not a choice, but it's still the same point. And 7, negative 220. So it could be choice 4. We're not done, though. Everyone all right there? If you're going to keep the 7 positive, you got to add and subtract 360. All right, what if I wanted to make it negative now? Hold on. So let's say 140 now, same point as negative 7. Now what do I add and subtract to my angle if I'm going to make it negative? What was the rule you just wrote down on the previous? Add or subtract what? Not 360, but 180, because you guys go on the opposite side when you graph it. So give me 2 other points that are the same as well. So I got negative 70, comma, negative 7, negative 7, comma, 320. Or I could have negative 7, negative 40. Guys, hey, everyone, take a look. 1, 2, 3, 4, all 5 points are graphed the same exact way. They're the exact same point, all 5 of those. All right, but only a couple are my choices, though, which are what? What are my choices here? Negative 7, negative 40 is up there. And so is negative 7, 320. So those 3 out of the 4 would be the same point if I graphed it. We okay there, making that clear? Because the only other thing I'm going to do to you today is now it's in radians. Okay, give me the same point now, but in radians. All right, what if I wanted to keep the 2 positive? If I kept the 2 positive, what do I do with negative 3 pi over 4? I add and subtract 2 pi, 360. Add and subtract 2 pi. You guys that weren't here on Thursday, we did this we shouldn't have to convert to degrees. You guys should be able to do this. Ready? Off to the side here. Negative 3 pi over 4. Hey, what would I change 2 pi into to get a denominator of 4? What's got to be on top here to make this equal to 2 pi? 8 pi, yep. You got to talk to me if you're having trouble doing that. I think that's the toughest part of this unit right now. And then you also do negative 3 pi over 4 minus 8 pi over 4. And what do you end up with? So I could have 2 comma, first one here, 2 comma 5 pi over 4. Or I could have 2 comma, what do I have down here? Oh boy. One job. Negative 11 pi over 4. I think only one of those is a choice, right? Yep, this one so far. We going too fast or we're right here? Okay, now I got to change the 2 into a negative 2, but now what am I going to do with the angle? So now change it into a negative 2, but do what with negative 3 pi over 4? Add and subtract what now? Pi, 180. All right, so negative 3 pi over 4 plus, hey, what are you guys changing pi into? Let's make a denominator of 4 so I can add them together. How do I make it a denominator of 4? What's got to be on top? 4 pi, yep. And then negative 3 pi over 4 minus 4 pi over 4. All right, what's 1 point going to be then? Negative 2 comma, what do you got here? Negative 2 comma, negative 3 pi plus 4 pi. Pi over 4. And then the other point, negative 2 comma, what do I have here now? Negative 7 pi over 4. What am I looking at? Choice 2 and 4, that's it. Okay. All right, we all right? Another quick day tomorrow. I'm coming around real quick. Can I see your Friday work if you were here, please? See your Friday work.